I am H, and welcome to my presentation on hydraulic jump and the shallow water equations. The intent is to compare modeling hydraulic jump using the shallow water equations in MATLAB versus Fluent, as well as different operating conditions in MATLAB. Hydraulic jump is a well-documented phenomena where the height of the water column rises quickly when the water slows abruptly. According to conservation of momentum, when the flow goes from supercritical velocity to subcritical, the cross-sectional area of the flow increases in a ratio with the Froude number. This value relates inertia and gravity forces dependent on the velocity just before the jump. This phenomena is commonly found in nature, such as tidal bores or rapids. It is also induced in man-made structures to control flow velocity. Structures include spillways, dams, and weirs. The governing equations used in MATLAB were the shallow water equations, a form of the Navier-Stokes equations where the z-direction is small enough to be considered insignificant. In this case, the eta value is simplified as h in these equations, where h is the height of the water column. This discretization for these equations was relatively straightforward, resulting in this wall of text. The important things are that since central differences were used for spatial terms, there is a 1/2 multiplied into the first-order terms. There was also a dampening term, b times velocity, added into the momentum equations. In ANSYS, a weir-like geometry was created in a channel. The mesh was inflated at protrusions and used default mesh size, except maximum cell size was reduced to 0.04. In Fluent, the problem was set as time transient with k epsilon viscosity. The PISO algorithm was selected due to familiarity and the large time step desired. A problem between Fluent and MATLAB that limits comparisons was that the flow velocity had to be less in Fluent in order to simulate the desired behavior. Also, the waves failed to be modeled in 3 dimensions, and only the xz plane modeled the desired behavior. In MATLAB, the u velocity was initialized as a gradient from 10 to 0 in the x direction. The v velocity was set as 0, and the height was set as a flat plane at a value calculated analytically as 0.3. The boundary conditions in the u velocity were set at 10 and a calculated value of 1.36. The other conditions were set up as free flow and then as no-slip channel walls. This plot is of the water height along the x direction around time step 10,000. The model values are good, although the exact behavior close to the jump is poorly modeled. Analytically, the jump height was calculated as 2.5 meters, and the MATLAB model comes close immediately at the jump and stabilizes around 2 meters. The oscillations shown are much reduced from earlier solutions. All in all, this is a good solution for this simulation. This is a counterplot of u velocity with the source, or u1, at the bottom of the screen and the channel mouth, or u end, at the top. Also taken at time step 10,000, the velocity clearly drops off quickly in the region where the height increases suddenly at about x equals 50. This video shows the solution of free flow boundaries. The wave forms relatively quickly and moves back until it stabilizes near where the u gradient is. The following video is the solution with the no-slip boundary conditions. The wave once again forms and is much smoother, but there are artifacts that occur where the v and u boundary conditions interact. The following video shows the desired water behavior in the Fluent solution. Note the jump forms shortly after hitting the ramp, although it quickly submerges below the backflow. Also note that a reverse jump is formed on the right side, where the geometry and drop induces critical flow again. The following is the u velocity plot of the same solution. Note that the low velocity forms at the ramp base where the jump occurs and increases past the weir, where it accelerates again. In conclusion, Fluent presents a more intuitive visual of fluid behavior, but requires either experience or trial and error to set up, while MATLAB modeling is less robust, but the values are easier to calculate. I am